Hey guys, this video is just for my teacher people to help you out if you're new to doing the paper plasmid activity. I love this activity. I think it's so awesome, but it can be a little overwhelming the first time you're doing it. So there's a different video in the description down below that shows the kids how to get the plasmid ready and the viral DNA. If you haven't already watched that, I would start with that. And then I'm going to take you through the thought process that I used with the kids from that point. So mine have a little notes organizer where they will have filled out what are the restriction sites and then what are the different rules. And I have a Nearpod that I did with them. All that's in my Google Drive. And then what I ask them to do is just go through and really think through each enzyme and whether it violates any of the rules. And then they're supposed to record that. They're going to have to explain it to me at the end of the activity. So if we start with the first one, which is green on here, one of the rules is that we can't cut into the origin gene. And if we cut with this one, we're cutting into the origin gene. That's really the only problem with cutting the plasmid with this particular enzyme. But if we look at the viral DNA, we can't cut off more than 20 base pairs at either end of the viral DNA. This would cut it 3 times, so that's a no-go on the viral DNA. So they actually have to tell me 2 reasons why they can't use that enzyme, or at least one of those 2 reasons. They could just give one. Okay, the next one, if we look at it, it doesn't cut too much off the ends of the viral DNA. We're okay. It's the one that's mustard colored. But if we look at the plasmid, it's going to cut the plasmid into many pieces. And our first rule is do not use an enzyme that cuts your DNA into many pieces. So I want to be specific. This one cuts the plasmid into many pieces. It would be fine for the viral DNA. When we get to the third one, it doesn't leave sticky ends. So the Hey3 is just going to cut right down the center. So no sticky ends. And we need sticky ends for it to be able to recombine with the viral DNA. The other problem with it is it's going to cut the plasmid in more than one place, and it's going to interrupt the antibiotic resistance gene. So there are actually several problems with this. This is actually the enzyme we're going to use, so I'm going to skip it for now. If we come down to the last one, let's see what the issue is with this one. Okay, so this one's shown in red. It looks like no problem on the plasmid. We would only be cutting the plasmid one time. It doesn't interrupt any genes, so we're fine there. But then if we look at the viral DNA, it cuts the viral DNA right in the middle, so you're cutting off way too much of the viral DNA. So that brings us to the enzyme of choice, the HIND3 enzyme. And for that one, it's shown in light blue. The kids are actually going to cut, and you might want to have them get your okay before they cut, or maybe you're okay with them just making mistakes and learning from them. But when they go to cut, it's probably good to mark the cut on there first. It does cut at a zigzag, and then do the actual cutting. So here's our viral DNA. It now has sticky ends. This enzyme only shows up once on the plasmid, this enzyme restriction site, which is what we want. We only want to cut the plasmid once to open it. And then the kids tend to get a bit stumped at this point. Take the end of the viral DNA that connects to the plasmid here and just tape it, so that represents our ligase. And then we do the same thing right here. And now we have our recombined plasmid, our recombinant DNA. This now has a hepatitis B gene in it, and so this could be used to help spur an immune response. So this is an example of a naked DNA vaccine where our body is going to recognize the protein that would be generated by this and start to make antibodies to it and have an immune response so that we could then become immune to hepatitis B. So I also have my kids explain what is the connection to vaccines, because they can get sort of lost if I don't specifically draw their attention back to vaccines.